Hello everyone. I again welcome you all to this wonderful event. I'm super excited to be here today. My name is Akshat Khanna. I am working as an MTS at VMware in the TKG Edge team. Today, I'll be talking about identity with certificates in Kubernetes. So this will be the agenda or the questions that we'll try to answer today. So the first thing is, what are certificates and PKI? We'll understand the basics of certificates and stuff. After that, we'll be covering why do we really need certificates in Kubernetes, how that is relevant to Kubernetes. Now, coming up next will be the how to create your own certificate authority and sign the certificate. Then we'll be covering how these certificates are actually generated. Then after that, we'll be covering certificate generation APIs in Kubernetes. Then comes the most important part that's the hands-on demo that I'll be giving. After that, I'll be covering the bootstrap certificate bootstrapping technique and the rotation steps. So without further ado, let's get started. Okay, let's talk about certificates in general. What are certificates and PKI? The certificates allow parties in a conversation to authenticate themselves and talk to each other. Think of a client and a server communication. The client can authenticate the server and the server can authenticate the client. It confirms that the communication is happening between the correct parties. A way of doing it can be both the parties can trust a third party and that third party can issue them so that they can trust each other. So this there is a certificate authority which issues a certificate to these components. Okay, now let's come to Kubernetes. What is the use of certificate? Why should we know about certificate? We assume that many people here are already using Kubernetes or might be start using Kubernetes after this event. So as we all know, Kubernetes is a distributed system. In this diagram, the it is an example of a simple Kubernetes cluster with some core components. The API server talks to all other components like scheduler, controller manager, etcd, kubelet, pod, container, etc. So we need to verify that all these interactions that are taking place are secure and authenticated, because any developer contact through all the components using this API server. So all these interactions should be secure and authenticated. This is the use of certificate in Kubernetes. Okay. Now, coming up next is the certificate authority, cluster certificate authority. So it is a trusted authority for entire Kubernetes cluster. All the certificates are signed, validated, and rotated when they come near expiration by this cluster certificate authority. It is used by all the components to validate and authenticate the requests. The CA issues the certificate to client and server so that they can use it. You can view in this diagram, the certificate authority issues the certificate to a server and the client. So the certificate authority is the root trusted service. And after it issues a certificate to both server and client, they can talk to each other in a secure manner. Okay, so coming up next, like how certificates are generated, how I can generate my own certificate and use it. So these certificates are generated through some open source tools like EasyRSA, OpenSSL, or CFSSL. So in this, I am covering how you can generate your certificate using OpenSSL. So in OpenSSL, you can run first command to generate your key. OpenSSL generate RSA. It will generate a ca.key file. After that, you have to use that and generate a CRT file. So you can run the second command. After doing that, you have to use those previous generated files and generate a server.key file using the third command. After doing this, we need to use the config and use the config so that I can generate the certificate later. So to do that, we have to generate a csr.conf file. After this, we have to run the fifth command using the ca.key file, ca.certificate file, and the server.certificate file that we generated in the previous step. After this, you can verify the CSR or the certificate signing request, and you can view the certificate in the text format using the seventh command, OpenSSL text and the certificate.crt file. Okay. In Kubernetes, you can generate the certificates in using two methods. First is using it automatically generating the certificates and signing them using the kubeadm if you are using kubeadm. Otherwise, you can manually generate the certificates using the certificate generation APIs. So Kubernetes offer API to generate your certificates and use them. So that is certificates.kx.io/v1. So it creates a certificate signing request, and that certificate signing request object is sent to the API server or the Kubernetes API. When the CSR is generated, it is in the pending state. So it is the work of the Kubernetes administrator to approve the CSR. So the Kubernetes administrator has to go ahead and approve the CSR so that it can be used. Yeah, so it is beautifully depicted in this flow diagram. In this, we have provisioned and initialized the certificate. Then a cluster administrator CSR and the configuration is generated. After this, the CA is generated. So CA is the, as I explained earlier also, CSA is the certificate authority or the uh, root service which all the other components trust, and all the certificates are signed and issued by CA. So this sends the signed certificate and key to the trusted services. These trusted services contact to each other or communicate to each other in a secure manner. So when the certificates come to expiration, they again hit the certificate authority and ask for a new signed certificate and the key. Okay, now coming up next, I'll be giving a demo in which first I'll show how you can generate your first certificate signing request and then approve it. Then after that, how you can create your own certificate authority, sign your certificate and issue your certificate. So without wasting time, let's get started. I am inside my terminal now. So before we begin, we should have a Kubernetes cluster up and running along with the kubectl command line tool to execute our commands. So currently I am using Kubernetes of version 1.22.5, and also we need a CFSSL tool, that is an open source tool to generate your certificates and the CSR. So you can go ahead and download the open source tool from github.com/cloudflare/CFSSL. This will help us to generate your certificate. So in interest of time, I have already generated a certificate. You can go ahead and follow the documentation given on the README and generate your certificates. Okay, so now let's begin generating our first CSR or the certificate signing request. Yeah, so to generate your certificate signing request, we have to run the command cfssl generate key and cfssl json bear server. So in this, we need to specify the host. Now this is my DNS of my service that is running in my cluster, and this is the DNS of my pod, followed by the internal IP of my service and the IP of my pod. And we also need to define the algorithm that should be used to generate the key. So when I execute this command, it gives me the output. The CSR is generated along with the key. So now let's check that out. So I can see that server.pem file and server.csr file have generated. So now let's check our certificate CSR that is generated. Yeah, and here I can see the output of my CSR. So this is my CSR that is generated. Now, once the CSR is generated, now we have to generate the CSR object to send it to Kubernetes API or the API server. So to do that, first let's check our certificate. We have the certificate signing request formed, and after that, now we have to send the certificate signing request object to the Kubernetes API or the API server. And to do that, we have to define Yeah, so here we have to run the command kubectl apply f and followed by the configuration. So in configuration, we have to define API as certificates.kh.io/v1, and the kind would be the certificate signing request, and the name would in metadata, the name would be the identifier name of our CSR that we are sending. So I'll name it in the spec rec- in the spec inside the request. You can see that we are passing the server.csr file that we have generated in the previous step in the base 64 encoded format, and also we have defined the signer name as example.com/serving along with the usages. And when I run this command, I get a response from the API server that the CSR has been generated. Now let's check our CSR. So I'll write kubectl describe CSR followed by the name. Okay, so this is the CSR that is generated, and you can see here in the status it is showing in the pending state. So whenever a CSR is generated and sent to the API server, it is in the pending state because the cluster administrator or the Kubernetes cluster administrator has to approve the CSR before processing it. So it is the status is still pending, and you can see all the uh, data here, like the signer, the DNS of the pod service, and the IP, and all the info that is listed here. Next, let's check out the status of the CSR that we have generated. We can see the CSR is listed over here along with the info, and we can see the condition is in the pending state. So the Kubernetes administrator has to go ahead and approve the request of this CSR. So to approve that, we have to write the command kubectl certificate approved followed by the name. Now we can see we got the response that the CSR that was generated is now approved. And now let's check again the status kubectl get CSR, and now we can see it is approved. Next, we have to sign the certificate signing request that we have generated. So to sign the certificate signing request, there should be a certificate authority. So certificate authority is the main root authority which is responsible for certificate signing and the issuing the certificate to a component in a cluster. So we have to create the certificate authority. To create the certificate authority, we have to run the command cfssl generate cert and cfssl json bear ca. So ca here stands for the certificate authority. We have to give the name of a signer. So I'll give the name of the signer as, and also we have to give the algorithm to generate the key. And when we execute this command, we can see the ca key and the certificate from the csr is generated. Now let's check that. Yeah, so I can see that the key, and this is the CSR, and this is the certificate. So everything is generated. Now after this, once we have generated, now it's time for issuing the certificate. To issue the certificate, we require some kind of configuration where we will define all the things. So this is the configuration file that I have generated already. So I'll show the contents of this. Okay, so in this server signing config.json, I have defined the expiry for the CSR and the certificate along with some different parameters. So you can also go ahead and create this config file to issue the certificate. Now let's go ahead and issue the CSR. Okay, so after to issue the CSR, what we have to do is we have to run the few of the commands. The command is kubectl get CSR followed by the name of the CSR that we generated in the previous steps. So I'll change the name here, and also this, and this should be passed in the base 64 decoded format so that it is visible in the unencrypted form, and then we can sign this. So let's execute this command, and I got the output as the signed certificate with serial number this. So now our certificate is signed. Now the next thing that we have to do is upload the signed certificate to the API server. And to do that, we have to run the command kubectl get CSR followed by the name of the CSR that we have given in the previous steps. And we want to get the output in the form of JSON, so that we have defined here, and followed by the name of the certificate and the key that we generated in the previous step that we are passing along with the certificate here. And also we have to uh, in this third line we also have to specify the name again of the identifier of the CSR that we. Okay, so now when I uploaded the signed certificate in the API server, I got this response. So this is in the JSON format. I got this response. Now let's check the status of our CSR again. kubectl get CSR. Now we can see that this is our CSR along with the condition approved and issued. So now our certificate is successfully approved by the administrator and issued to the component. After it is issued, we can also see our certificate. So to see the certificate, we have to run the command kubectl get CSR followed by the CSR name. So we'll give our name that we created in the previous steps, and we are base 64 decoding it. When I hit enter, so this is my certificate. I hope you learned something new today. And after this, the next thing that we are covering is certificate bootstrap and notation. So when you saw that I issued the certificate and all those things, so these are few of the steps that were taking place behind the scenes. That was like there is a approving controller that approves the CSR automatically, and there is also a signer controller that signs the certificate for you when we wrote the command. Okay, now what is certificate rotation? This is the last topic that we are covering today. So by default that these certificates are generated for 1 year so that they are not to be renewed too frequently. But there might be a case in which your certificate is near expiration. So in that case, there is automatically a key and a request for a new certificate is generated to the API server, and it can give you a new certificate, and that can be used for authentication of the connections. Okay, now coming up next we have is how you can enable client certificate rotation. So for doing that, there is a queue when you run a kubelet process. In that you can give the command rotate certificate, that will automatically request a new certificate when your certificate approaches expiration. And also you can give the duration of the certificate and CSR how long it should be available. That is in the second point. The argument is cluster signing duration. In this you can give how long the certificate should be issued for. I know the contents were a lot to be covered, but there is a very limited time, so I was able to cover this. Thank you very much, everyone. Now, please, it's time for you to ask question. Do you have any questions for me?
Hi, thank you so much for joining us. If we could switch back to the questions, sorry, I forgot to bring my phone up with me. Oh, we've got two questions. Wonderful. How to ensure, or how do we ensure that the CSR is coming from a legitimate entity, and how do we verify the signing CA that CSR is legitimate? I was missing some trust here, says the anonymous.
Okay, yeah, that's a good question. For this, I would say that we create a private key and a public key that is given to API server as well as the components. So the when the connection is taking place and they are sending the request and the response, at that time they validate that whether it is coming from a legitimate source or not through those keys. Yeah.
Okay, and we had one other question as well. Can we switch back? Oh, we have two more now. Wonderful. Can a rotation be triggered if the certificate is already expired?
Um, yes, definitely. You can check the expiration date, and also you can set it well in advance. So if you are using KubeADM, then it will then you are safe. Then it will rotate your certificate automatically when it is near expiration. But yeah, like if you are not using ADM, then KubeADM, then you can manually rotate the certificate at the time of rotation expiration. Yeah.
Okay, wonderful. Thank you. And how would you suggest to revoke certificates? Great question.
Okay, revoking means how we can rotate that. So that can be done using simple parameter that we can pass in the through kubectl command. Also, we can do that through parameter, or if you are using kubeadm, then as I told, you are safe. That can be automatically rotated.
Okay, wonderful. Well, thank you so much, Akshat. Oh, one more. Sorry, one just came through. How do you integrate a third-party enterprise CA?
Yeah, so like there are many third-party enterprise CA coming up nowadays. So there are many products for that. So that can be simply integrated through the API system. As we all know, the Kubernetes works on API, so that can be easily integrated through APIs and the keys that they exchange while they are communicating.
All right, I'm just trying to see if I can make sure that we're not missing any. Okay, we're not missing any. That was it. Thank you so much, Akshat. And just a reminder, Akshat's also available through the CDS platform. So if you have any more questions for him, you can, of course, contact him that way. Thank you so much, Akshat. Let's get a round of applause, please. Thank you.
Yeah, thanks everyone. Do catch me on the platform.